So as turbines get larger and larger and the rotors tap into wind resources at a higher altitude above the ground, turbines experience a more non-homogeneous inflow because of the wind veer and shear across the rotor that can bring the rotor into a severe off-design operation. And it's really hard to measure these effects through meteorological masts. But LiDAR, ground-based but also nacelle-mounted LiDARs, by virtue of the capability to scan the volume in front of the rotor, can get a much more accurate estimation of the not only wind shear but also the rotor equivalent velocity, which is really relevant for both performance characterization but also load assessment.
LiDAR is important in the wind industry because LiDAR can be used to measure the wind anywhere you want to without needing to construct an expensive Met tower. And also LiDAR can measure at heights that are beyond what traditional Met towers can reach. And that's important as wind turbines are getting larger and larger.
I think LiDAR is an important technology for the wind industry today because it gives us a bigger picture of what's happening in the vicinity of a wind turbine, both in front of a turbine and behind a turbine.
The LiDAR technology is a cutting-edge tool that has been evolving a lot, but in the recent year has achieved a level of maturity that now has comparable accuracy for the characterization, at least of the inflow of a turbine to traditional instrument, and has been introduced inside the IC standards recently.
I think it's really important that nacelle LiDAR is becoming more trusted for power curve verification. There are a lot of advantages in that it's going to always measure the inflow to the turbine, no matter which direction the turbine's facing, and it's getting a more direct measurement of the wind that's coming towards the turbine compared to a ground-based LiDAR.
LiDAR measurements can be extremely useful to plant operators. One of the more common applications is looking at wake behavior. So, for example, we as scientists often say that wakes in the daytime from turbines tend to be fairly short as they erode from all these updrafts and downdrafts of the atmosphere, and at nighttime they tend to be a lot longer. What LiDAR measurements let plant operators know is, we think that's happening, but is it actually happening? And so you can look at that wake behavior, that measured wake behavior, and as an operator you can also look at your plant power production, and you can see, am I being impacted more severely by wakes during the daytime or the nighttime? Also, you can look at the structural behavior of turbines as well, daytime, nighttime, and you have the LiDARs measuring the atmosphere to really give you a better sense of what's happening.